Hey guys, so obviously I'm at training again, so I'm doing another video for you. So we're going to pick up where we left off in our notes. So you should turn to 3.1 notes day 2, and it should say using function notation and testing solutions in a linear equation. So remember how to use these notes. If you need to go to the book and look at any examples in the book, you would go to 3.1, and then the title would be what you would want to Google or use in Khan Academy or whatever, because that tells you what it's about. So our learning target, today you're learning how you can model a real world situation using a linear function. That's a really broad learning target, and you're going to see this one over again for the next couple of lessons because it takes a little while to get there. But specifically for today, you'll know you're successful if you can list the characteristics of a function, you can determine whether a relation is a function, and you can identify the domain and range of the relation. And you're getting a bonus success criteria. This is not technically an 8th grade requirement. But you're going to see this notation, so I feel like it's really important for you to be able to use it if you're going to see it. So I'm actually going to start with this bonus. So function notation is just another way for us to write equations that have y and x involved. And so we use this thing called f of x. That's how you say it, f of x. I put it right here for you, f of x. Or sometimes you'll hear teachers or professors or whoever use f is a function of x. That's kind of the long way to say it. I always say f of x. You can call your functions whatever you want them to be. F does not stand for function, it's just the name of the equation. So you could use g or h or whatever letter you feel like. So if we're dealing with multiple equations, we would name them all different letters. So maybe I have 3 equations. I'm going to use f of x, g of x, and h of x to tell you the difference between whatever equation I'm looking at. F of x is exactly the same thing as saying y. So if you look right here at the top of these tables, f of x equals x plus 4 is exactly the same thing as saying y equals x plus 4. So really the big thing that you need to remember is that f of x is y. Those two things are exactly the same thing. So I wrote these backwards. I really should have these tables the other way around because f of x is over here and y is over here. But we can pick any numbers we want to for x. So let's say -1, 0, 1, and 2, just to keep it simple. And if I were to take -1 and substitute it into this equation, I would have -1 plus 4, which is 3. So y's value is 3. Well, let's plug the same numbers into the f of x equation. So I'm still taking -1 and plugging it in for x or substituting it in for x, so -1 plus 4 is still 3. So I'm going to get exactly the same results. However, you might see it written like this. And what they did was they replaced x with -1. That's all it stands for. They substituted -1 in for x's spot. So let's take a look at the next one, just so you can see a couple more examples with that. If I plug 0 in, I have 0 plus 4, so I have 4. And if I were to write it in f of x notation, see I replaced 0 with x, where x would be, the answer is still 4. 0 plus 4 is 4. So that didn't change. If I plug in 1, I'd have 1 plus 4, I get 5. If I plug in 1, I'd get 1 plus 4, I get 5 again. Okay, so nothing crazy. If I plugged in 2, I'd get 6 in both cases. So that's the notation. So I want you to be familiar with that.